afternoon, everyone. Today, we're going to learn about the specific details of frozen soil and subgrade construction in rainy areas together. In the southwest and southern parts of our country, there are high cold or rainy areas. If conventional methods are used for highway design and construction, it will inevitably lead to highway diseases such as frost heaving, settlement, and frost boiling. Therefore, special measures are needed for construction in these areas. Next, let's learn in details. I believe you are familiar with the concept of frozen soil. In high latitude and high altitude areas, due to severe cold climate, the temperature of the soil below a certain depth remains below freezing. Such soil layers are called frozen soil layers. According to the freezing time limit, it can be generally divided into perennial frozen soil and seasonal thawing frozen soil. If it does not thaw for 3 years or more, it is called perennial frozen soil. In the surface layer of the soil in perennial frozen soil areas, there is a cyclic melting in the warm season and freezing in the cold season, which is called seasonal thawing frozen soil. During the freezing process of subgrades in seasonal freeze-thaw areas, the moisture in soil moves upward continuously, which greatly increases the moisture content in the upper parts of subgrades. During the spring thaw, due to the excessive moisture content in the soil, the strength decreases rapidly. Coupled with the effect of traffic, phenomena such as springs, cracks, bulges, and mud pumping occur on the road surface, resulting in frost boiling. The major factors affecting highway frost boiling are soil quality, temperature, water, road surface structure, traffic load, etc. Among them, soil quality, temperature, and water are the 3 natural factors that form frost boiling, and they must act simultaneously to cause frost boiling. China's frozen soil areas are mainly concentrated in Tibet, where the famous Qinghai-Tibet Railway was constructed. From these precious historical images, we can see that the construction of the Qinghai-Tibet Railway was full of hardships. It is a road symbolizing the unity of the Chinese nation, built by the People's Liberation Army Railway Corps during the wartime, racing against time. Up to this day, the Qinghai-Tibet Railway still winds its way across the Qinghai-Tibet Plateau. Now, let's learn how to treat frozen soil with a sense of national pride and honor. The image shows an untreated highway located in a frozen soil area. For frozen soil subgrades, in sections with cohesive soil and sandy soil foundation base, when replacing the fill, the original foundation soil should be excavated according to the actual site conditions. Gravel should be filled and compacted in layers to ensure the compaction below the road channel. The fill height of the structural layer should be greater than 80 centimeters. In sections where the fill height requirements are not met, the treatment depth must reach 80 centimeters. In wet and soft subgrade bases such as paddy fields and wetlands, a permeable isolation layer should be installed, and the effective thickness can be determined based on the specific situation. For the selection of road embankment filling materials, slag, furnace slag, fly ash, sand, gravel, and crushed stone are suitable materials with good frost resistance and stability, as shown in the image displaying graded crushed stone materials. When the roadbed or upper embankment is filled with silty soil and clay, stabilizing treatments such as lime, cement, and soil stabilizers can be used. The improvement or treatment of filling materials should be determined through experimentation. Depending on the specific terrain and groundwater level conditions, drainage engineering for embankments should be well planned, including deepening drainage ditches and catch water drains, and adding blind ditches and seepage trenches. In addition to frost and thaw diseases, Highways can be also significantly reduced lifespan and usage levels when subjected to water damage. During the subgrade construction in rainy and humid areas, the following construction points should be noted. 1. During subgrade construction, special attention should be paid to drainage, and pre-construction site preparation should particularly focus on eliminating surface water. 2. In rainy and humid temperate regions, where the soil has high moisture content and the groundwater level is high, it can affect the stability of the subgrades. Side slopes of embankments should be protected with mortar rubble masonry pavement to prevent erosion. 3. When embanking the subgrades, a cross slope of 2% to 4% should be created on each layer's surface to facilitate drainage. The filling of soil on the same day must be compacted on the same day. 4. Outside the slope protection road at the foot of the embankment berm, larger cross-section stone-lined side ditches should be set up to lower the groundwater level. 5. When the moisture content of the wet soil is within 2 meters, wet soil can be excavated, and suitable dry soil or excavated stone slag, natural gravel, etc. can be filled and compacted in layers to be required compaction density. 6. After removing the silt, the soil layer can be loosened and crushed, mixed with an appropriate amount of quicklime powder, and compacted to the specified compaction density to form a stable soil reinforcement layer. 7. When non-weathered large stones block are available, after removing the soft wet soil, fill in the stone slag, compact it with a heavy roller, and build the embankment. For highways below the secondary level, stone filling can be used to fill and squeeze out the silt, and the embankment can be built after leveling and compacting. These are the key points of construction for frozen soil and subgrades in rainy areas. I hope you can understand and master them. Thank you.